This video is going to introduce piecewise functions and more specifically how to evaluate a piecewise function. But before we can do that, we have to know what a piecewise function actually is. So I gave you just a little definition. The reason we call it piecewise is there are going to be different sections of this graph or this function that behave differently depending on what x value I am using in any given situation. So in terms of what a graph would actually look like, this is the graph or an example of a graph of a piecewise function. You'll notice there is a section that behaves like this linear function 10 minus x. There is one specific point in this case, and we also have a piece that behaves like x squared or a quadratic function. So this one would be a collection of three different functions all together making this one piecewise function. So when I talk about evaluating, what we're going to do is my goal is to find the y value that would be associated with that specific x value. And in order for us to do that, by looking at a graph, I need to know a couple things ahead of time. First and foremost, equal to and not equal to. In terms of a graph itself, an open circle means not equal to, a closed circle means equal to. So in this case, or any graph that I show you with a piecewise function, if I have an open circle and a closed circle that are both on the same x value, which we're about to look at here, the closed circle is the one that defines that x value. So if I start with f of negative 3, or the function at negative 3, I'm going to look at the x value of negative 3. And I'm going to draw a dotted line here so you can really see what's going on. You'll notice that I have a closed circle down here and an open circle up at the top. That open circle for the value of x equals negative 3 is not valid. So in this case, for the function at negative 3, I'm going to use the value of negative 2 as my y value. Same idea with 0. If you look here, I've got two circles, one open and one closed, on the same x value. Open circles do not count because they are not equal to at that specific value. So here I would use 0. And for the function at 2, I'm going to look at the x value of positive 2 and find where that would line up, or where that y value would be associated with the x value of 2. And in this case, it's living on this linear piece here. I don't have to worry about an open circle or closed circle because it's just the solid line. So this would be an x value of 2. I'm going to show you another graph. This would be a really great time to pause the video, see how you do without me, and then hit play and see if you got it right. So with the value of the function h at x equals 1, open circles do not count because they do not have the equal to property associated there. So I'm going to use this circle here, which is closed, which means it does equal this specific point here. So the value of the function h at 1 would be 2. I'm going to do the same thing with 3. Figure out where it's living. In this case, it is on that linear function. I don't have to worry about open and closed circles again because this is a solid line. So all of these are valid points. So in this case, it would be 3. Now we're going to switch it up a little bit. Instead of giving you a graph, I'm going to give you the actual function itself. Yes, it looks a little intimidating right off the bat, but I promise you they're not that bad. So my goal right now is I'm dealing with the function f at x equals negative 2, or the function at negative 2. In order for me to do this, I need to look at these condition statements over here. And what those tell me is where the function would be behaving like x minus 2 or x plus 3. So in this case, for the value, or for the function x minus 2, the piece of my graph that will behave like that linear function are all of the x values that are less than or equal to 0. And for the function x plus 3, that specific piece will be all of the values of x that are greater than 0. So I'm going to take f of negative 2, and what this means to me is the value x equals negative 2. And my goal is to figure out which condition statement that would be valid in, or would actually be a true statement. So my value of x is negative 2. I have to think, is negative 2 less than or equal to 0, or is negative 2 greater than 0? Which one of those is a true statement? Because negative 2 is less than or equal to 0, the first condition is what makes it true. So that tells me that that specific value will be on the function x minus 2. So I'm going to take my value of x equals negative 2 and substitute it in where I see x. So negative 2 minus 2. And what this is going to tell me is that my y value associated with this piecewise function at x equals negative 2 is negative 4. And what I'm going to do is step away and let you try these tonight at home. We'll talk about them tomorrow. Make sure everybody's on the same page before we start throwing some word problems into the mix. I'll move that out of the way. If you have any questions, jot a note down in the corner of your notebook page and we will talk about it tomorrow.